Kia ora, Year 12s. Hope your exams are going well. Just wanted to put something together for the work that you're missing out on in class this week. So what I'm going to do is going to be different from usual. It's not going to be revision. I'm basically going to do a short version of what I've done in class. We're working on the remainder theorem and the factor theorem. So it's part of complex numbers, but it hasn't got any surds in it and it hasn't got any imaginary things in it. We're going to work from Delta and New Lake. In Delta, it's page 236 onwards, chapter 26, and we're going to start with some long division. Okay, so just a bit of notation first. We're working with polynomials in this part of the topic, and we're going to write any polynomial as p of x. Now, that notation is going to be useful to us later, so I want you to start getting used to that. So an example of a polynomial would be this function here, 4x to the power of 5 plus x squared plus 72x plus 1, and we say that that polynomial has got degree of 5, okay, because we look at the highest power of x that we've got there. Now, they turn up in complex numbers because we're going to be interested in solving these types of equations, so usually making that equal to 0, and we're going to want to try and factorize them and to find solutions, and it turns out that all of these polynomial equations have got complex solutions, right? So now we're going to go right back to basics and look at some of the vocab around division. Okay, so this is all just coming out of Delta, right? So nothing particularly fancy. Just the language that we're going to be using, you're not going to be used to using it with algebraic expressions, but it's all goes way, way back to primary school. So if I go 16 divided by 5, we're going to call 5 is going to be the divisor. I don't know why I'm writing this because it's all up here. So the divisor is 5. The dividend is not a piece of financial jargon here. It means the thing that we're dividing by, and that's 16. The quotient is the whole number that we get when we do the division. So if we divide 16 by 5, we get 3, and we get 1 remainder. So we say the remainder is 1, and the quotient is 3. And we're going to do long division like this. Using algebra. Now, we did that in integration, but I think many people didn't really like it and tried to avoid it, but I want you to get the hang of it here. There's another YouTube video already on long division, so if you don't feel like you've got it after this video, you might want to go back to one of the very early ones from about February and take a look at that. Okay, so we're going to start with a little bit of practice at long division. We're asked to divide this polynomial. So this is my p of x, and we're going to divide it by x plus 3. Just get rid of that, I'm going to need a wee bit of room. Okay, so we write x to the power of 4 minus 3x cubed plus 2x squared plus x minus 4 there. So that's the dividend, right, the thing that we're dividing by. Sorry, the thing that we are dividing, and then this is the divisor here, x plus 3. So it's just like if we were doing 16 divided by 5. Right, now we're going to do a thing where we basically try to say, let's do some matching up. So x times what will give me the first number here? X times x cubed will. So we'll have x cubed times this expression. Gives me x to the power of 4 plus 3x cubed. Right, whack a bracket around that and subtract it. If you're not familiar with this long division, you might want to stop the video and go and ask your parents, because they will definitely remember it. It's the stuff of 1970s and 80s maths. So, what we have now is we're going to subtract this line from the top line. So, starting over here, negative 3x cubed minus 3x cubed gives me negative 6x cubed. Here I have x to the power of 4 minus x to the power of 4. So we've done that on purpose so that that leaves us with 0. Now I bring down the 2x squared. I've got plus 2x squared here. And I go back over to here and I say, let's look at the x plus 3. X times what will give me negative 6x cubed. So it's going to be minus 6x squared. And off we go again. So negative 6x squared times this gives me negative 6x cubed minus 18x squared. Bracket around it, subtract it, so we get 0 here. 2x squared plus 18x, be careful with that, gives me plus 20x squared. All right, bring down the x, plus x. Right, oh, getting very messy here. I've erased the whole thing. Hang on. X plus 3 here. So, again, x times what will match up to the 20x squared. It's going to be plus 20x. So we'll have 20x squared plus 60x. Right, subtract all of that, and we get negative 59x. We bring down the 4. Right, so what times x will give me negative 59x? It's going to be negative minus 59. We get the very unpleasant negative 59x minus 177. So that leaves me, and I've run out of space, that leaves me with a remainder under here of negative 4 plus 177 with a remainder of 173. Now this is exactly the example out of delta, both the new delta and the old delta, so it's page 237 and it's the first example, so you can work through it in the book. What we find is that the quotient is this thing up here, right? This is the divisor, and this thing here is the dividend. And this is my remainder. So we're going to do a couple more of those, and then we're going to look at another way to think about this. Okay, so this one looks innocuous. We're asked to divide 3x cubed minus 5 by x minus 2, and then we're going to write it in quotient plus remainder form. And again, this is delta, page 237. I'm just stealing their example. I hope they don't mind. Maybe I hope they don't see. So the trick here is to write in zeros for the missing powers. So that's 0x squared plus 0x minus 5. And we're doing that because what we're doing here is a lot like dealing with place value when we do long division with numbers and decimals. So off we go again. We're going to say x times what will give me this? 3x squared. So we get 3x cubed minus 6x squared. Here we're going to get 6x squared. Bring that down. Write down the plus 0x. It's going to work better if we do. Then we're going to go plus 6x because I'm saying what times x will give me that thing there. And that will give me 6x squared minus 12x. Subtract that, we get 12x. And here we get, bring down the 5. So x times what will give me 12x plus 12. Okay, so we get 12x minus 24. So we get a plus 19 here. So we can write this 3x cubed minus 5 over x minus 2 is equal to the quotient, right, the bit that falls out from the top, right, this, I'm going to call that q, plus my leftover, 19 divided by x minus 2. So the remainder in here is 19. Okay. Now another way we could write that is we could write 3x cubed minus 5 is equal to 3x squared plus 6x plus 12 times x minus 2 plus 19. Okay, so that's multiplying everything through by x minus 2. Okay, so I want you to be comfortable with being able to do long division, although the two things we're about to learn means you might be able to avoid it some of the time. Right, so what is the remainder when this expression is divided by this one? So we're going to do this same kind of idea. We're just going to have 3 terms in the divisor, but that doesn't matter. So 2x squared times what will give me 4x squared? 2. So here we'll get 4x squared plus 6x minus 14. Let's subtract that off. We're going to have negative 7x plus 11 plus 14, so it's going to be plus 25. So the remainder will be negative 7x plus 25. Okay, we're going to look now at a thing called the remainder theorem, which is going to give us a much faster way to find the remainder when I've got a linear divisor. In other words, a divisor which is something like this, 2x plus 3 or x minus 4. Now when we did this in class, we played around with this until students noticed it, but because I'm doing a YouTube video and trying to go quickly, I'm just going to teach you how the theorem goes, which is much more boring. The remainder theorem is a really cool thing that says if I've got a polynomial and I divide by a factor x minus a, I can figure out the remainder by just substituting a into my polynomial. Now that sounds like gobbledygook until you see it done. Suppose I've got x squared minus 3x plus 5. And I'm asked to divide it by x plus 2, but I want to know what the remainder is. Well, I start off by writing it as p of x is equal to x squared minus 3x plus 5. And I'm dividing by x plus 2. So you can think back to when we were factorising little quadratics. If I had x plus 2 was a factor, this thing here would equal 0 when x plus 2 equals 0, or when that did. So that was when x equals negative 2. So in here, to find the remainder when I divide by x plus 2, all I have to do is to substitute in x equals negative 2. And that's going to give me my remainder without doing any long division. All right, so in class we had half the class did it one way, and then half the class did it this way. So we get 4 plus 6 plus 5. Okay, so we're looking for what is the remainder? Well, it's going to equal 15. Remainder is 15. So we didn't have to do any long division. So this is because of this thing called the remainder theorem, right, which lets me get the remainder very easily. I'm going to do a couple more examples, so there's one more here, and then I'm going to break the video into two halves. So we're going to calculate the remainder when x cubed minus 2x plus 1 is divided by 3x minus 2. So pause the video and have a go at it. If you don't know what to substitute, think about what we did over here, where we were dividing by x plus 2. So we wrote that out as a little equation of x plus 2 equals 0, and we solved it. And that told me what to substitute. So try doing the same thing on this one. Alright, so we've got x cubed minus 2x plus 1, and we're dividing it by 3x minus 2. So we look at our linear divisor and we say, well, 3x minus 2 equals 0, so 3x equals 2, x equals 2/3. We're going to substitute this in to my polynomial. We're going to evaluate p at x equals 2/3. So it's going to be 2/3 cubed, don't even think about changing that to a decimal, minus 2 over 2/3, and it's a plus 1, that's a plus up there. So that gives me 8 over 27 minus 4/3 plus 1. Okay, so simplifying all of that over 27, it's going to be 8 minus 4 9s are 36 plus 27, which gives me 35 minus 36, which is negative 1 over 27. Okay, fine if you must, in the interest of time in the exam, to do that in your calculator. Okay, so that's how we use the remainder theorem. We don't have to do long division. We can figure out a remainder by just substituting in the appropriate value of x into the polynomial. Now it works when you've got linear factors. It's not going to work for ones where you're dividing by a quadratic. That's all for now. I'll do a second video with the factor theorem, which is what we did today, Tuesday.